Hey there, I'm Nix, and today we'll be solving a problem continuing with my Get Started video set. As per usual, I'll go over all of the details of the process to solving the problem, through the planning stages, to the coding of it, to the analysis of its time and space complexities, and looking at its LeetCode rankings. If that sounds interesting to you, then stay tuned. Welcome back. Now to find our next problem. As usual, we have the acceptance sorted and ranked according to the highest acceptance rate we have, which should give us nice, easy problems to help get your feet wet and get started on solving all of the problems in the LeetCode website. So we've done this one. I'm skipping over all of the orange locked ones because that requires premium access, which I don't have. So we're just going to skip all the ones that you need to pay to get access to and find the next one that you don't. So next is running sum of a 1D array. Click on that, and here we are. We are going to be given an array called nums, and we define a running sum of an array as running sum I being equal to sums 0 all the way to I. And we want to return this running sum of nums. Okay, to better illustrate the example is an example. We have nums of 1, 2, 3, 4, and we want to output 1, 3, 6, 10. And as the explanation shows, our running sum is the first one does not change, it's still 1. The next one, in the original was 2, the next space is 3 because 1 plus 2 is 3. Next one is 6 because 3 plus 2 plus 1 is 6. And finally we have 10 because that's the sum of everything. So we have a running sum as we go through the array. And we also see that in example 2 and example 3, so on and so forth. Our constraints here, we're never going to be given an empty array, that's nice. And our nums values can have a fairly large range to them and dip into the negative. Okay, so two main ways strike me as methods to solve this problem. One uses memory, one is an in-place solution. So let's tackle the one that uses memory first, and then I'll show you the in-place solution. So if I'm going to use some memory, why don't we just carve out another array to hold all of the new values, the summed up ones. Then all I need to do is loop through the original array and essentially use this as the code to set the value of that new array at that position to the sum of the current number and the previous number. And then after that for loop, you just return that new array. So let's look what that code would be. First up are our variables. We have the vector of integers, the new array that I call sum array. And since this is going to be exactly the same size, hold exactly the number of values that the original did, I just pre-allocated its size to be equal to num size. And finally, I have an integer that I named running sum, and I've set that initially to 0. Next up is the loop, typical one here, and within it, my running sum variable is going to be equal to itself plus the current number. And in that way, I have that value equal to the current one plus the previous value of the old sum. And now all I need to do is set the sum array at that position, I, equal to that value, running sum. Last thing to do is outside of the for loop, so we simply want to return that new sum array. And with that, the code is complete. So let's see if I've made any mistakes in my creation of it. So we get an accepted here. Everything equals what it should. So let's do the full shebang, do a submit, and I haven't messed anything up. Great. Now, in terms of the analysis here for time and space complexities, this one has a good time complexity, but a not so good space complexity, as you might have guessed. Because we are carving out a new variable vector, we are carving out variable space that is dictated by the size of the nums array. And because we depend linearly on that variable, our space complexity is going to be equal to big O of n, where n is the size of the nums array. For time complexity, we only have this for loop to worry about, and everything within the for loop is doing work that takes a constant amount of time to do, which means the time that it takes this for loop to run is primarily dictated by the number of iterations it's going to do. The more iterations this for loop goes through, the more time it's going to take. And since the for loop is also dependent on the size of the nums array, this is also going to be a big O of n time complexity. And you really can't get much better than that, since you have to traverse the nums array in order to sum up all the numbers. There's no way around that. Now to look at our rankings before we go ahead and go to the next problem. Not too big of a distribution here in terms of runtime, so I would definitely be able to see some back and forth between whether it thinks I'm here, which for now it does, or whether it thinks I'm here, and there's really not a huge difference. So moving on to the memory. It did not register on the graph itself. What did it tell me my usage was? I can't remember. But it's probably beyond what this shows, and resubmitting this exact same answer would probably get it to show up somewhere around here as it ping-pongs back and forth. But in essence, we have a very low memory score. Now the next solution that does an in-place way of solving the problem will seek to maintain our good runtime while improving our memory usage. So let's go back to the problem. Let's reset this. Now we want to solve this problem without making that new vector. And we can do that by running through the nums array and overriding the values as we go through. The first value you see in all of these examples never ever changes from the output. So really we can start our walkthrough at the second position, or the value with an index of 1 instead of 0 here. Then what we want to do is to get this new value, we look at our current position's value and add it with the previous one. 2 plus 1 will give us 3. That overwrites it, so now our array would be 1, 3, 3. And as you can see, if we do the exact same thing, move to this index, sum its value and the previous value, which has been modified to the new value of 3, 3 plus 3 is going to be equal 6. So at this stage we would have 1, 3, 6, and the old value still remaining, the final one, of 4. And of course 4 plus 6 is going to be equal 10, which is overwritten in that position. Then, after that for loop is complete, we just return our nums array and boom, problem solved. So let's look at that code. No variables needed this time, so we're going right into the for loop. As I stated before, the only change for this for loop is we're actually starting at the first index, not at 0. And what we want to do is all the way until the end, we want to take the value at that index, nums I, and set it to itself plus the previous value, nums I minus 1. And that will do exactly what we described earlier when we were planning this out. This also reinforces that we really need to start at the index of 1, because the previous index will point it to the very start of the array. But if we had this exact code here and this index was 0, we'd get an out of bounds error because we'd be pointing it to an index of 0 minus 1 or index of negative 1, which is out of bounds. Finally, we want to return nums and ensure I didn't mess anything up by clicking buttons now. Click the button. Yes, click. Running, accepted, great. Let's do the full submission and hope for green text. Excellent. Now with this, we don't have the need for carving out extra memory use. And so while our time complexity is pretty much the same, we still have big O of n here, our space complexity is now big O of 1 because we don't have extra memory being carved out from that new array. And as you can see here in the preview, time complexity ranking should be good. Space complexity ranking should be not so good. And you see here, these two I think are the same solution. These two are the same solution. You can see it ping-pongs around occasionally. But let's go ahead and look at the graphs just for giggles. This hasn't changed any, and this hasn't changed any. So that was worth it, wasn't it? Anyway, that was the running sum of a 1D array problem. I hope this video helped you out in some way. If it did, consider subscribing. And with that, I will wish you happy coding and to have a nice day.